Though the beginnings of scientific inquiry can be traced to the Greek philosophers, the way modern science is done started some 400 years ago. It started around the time of Francis Bacon, who is generally regarded as the father of science. In his monumental book Novum Organum, published in 1620, Francis Bacon made a very important remark in the first line of the book. He said, "Man, as the minister and interpreter of nature, does and understands as much as his observations on the order of nature, either about things or the mind, permit him, and neither knows nor is capable of more." This is a crucial point for our present discussion. Let's dive in. He has pointed towards the capacity of humans. We only have a certain capacity. We can't know everything. We can't transcend that capacity. We can only know as much as our observations can inform us. We can only know the limit our brains can capture and assess. We cannot go beyond that. And Bacon argued, those who are under the impression that we can transcend that limit are only living under a self-imposed delusion. He discarded all the intellectual activity before him as gibberish and proposed a new method of seeking reliable knowledge. With Bacon, the centuries-old tradition of armchair, mindless, speculative philosophy ended. Earlier, if someone could say something that sounded sophisticated, he obtained respect. Bacon criticized it and rejected it and started what was called the experimental philosophy. Following this messiah of scientific experiments, René Descartes, after him, appeared on the stage. He devised what is called the rational methods of inquiry. He said, "Doubt is the origin of wisdom." With him, the act of doubting turned its color. Earlier it was condemned. Descartes blessed it. Descartes blessed doubt. Since then, a cascade of scientific activity started. Scientists after scientists began to collect samples, record observations, seek patterns, devise theories, and discover laws. Since then, we have discovered the laws of mechanics, the laws of thermodynamics, the periodic table, the taxonomy charts, statistical mechanics, laws of electromagnetism, human anatomy and physiology, laws of chemical combination, theory of evolution, theory of relativity, laws of quantum mechanics, and the list goes on. The 400 years of scientific activity proved so successful that it not only transformed our knowledge about the world, but also changed the way we live and prosper. It has only proved that among the crowd of Enlightenment thinkers, the methods and principles of Francis Bacon have by far become successful. But in the last 100 years, people have begun to see a pattern. That probably we are now stuck. That we humans have perhaps reached our upper limit. We cannot seek further. Earlier, the scientific spirit was characterized by a belief in the dichotomy of the known and the unknown. The universe is made up of that which is known to science and that which remains to be known. In other words, there is nothing that cannot be known by science. The unknown will remain unknown only until science illuminates it. But in the last century, the unknown broke into two pieces: the unknown and the unknowable. The last century brought us face to face to so many things about the world that will remain unknown. In the domain of the smallest, we had hit a wall called the uncertainty principle. In the domain of the largest, we had hit another wall called the speed of light. In the domain of the complex, we have hit yet another wall called the non-linearity. And in the domain of knowledge itself, the capacity to attain knowledge, or epistemology, we found the biggest elephant in the room. It was called the Incompleteness principle of Gödel. It states that no matter how hard we try, none of our theories about the world is ever going to be complete. Incomplete theories are the ultimate fate of the seekers after truth. In the year 1996, John Horgan published a book called The End of Science, and later in the year 1998, John D. Barrow published a similar work called Impossibility. Both of these works were published at the end of the last century. Both argued that indeed we have reached the limit of human endeavor, that we are stuck, and that we perhaps cannot do anything about it. This seems to be true, but in a certain domain of inquiry. We cannot progress in a certain direction of inquiry. But there is yet another domain of inquiry, another direction of inquiry where there is still hope, and quite a considerable amount of hope. We cannot proceed in the direction of refining our knowledge, as it seems. We cannot perhaps cross the barrier created by the uncertainty principle. We cannot see what lies at the heart of the nuclei. I mean, although we have figured out what is called the standard model of particle physics, which can explain more or less every phenomena in the atomic and the subatomic domain, we cannot dig further. We cannot go on making observations narrower and narrower. Similarly, in the domain of the largest and the heaviest, which is the domain of Einstein's relativity, if you allow both space and time to change in a connected way, then everyone will agree that light moves at a universally constant speed. But for space and time to change in a connected way, they have to be one big continuum. Otherwise, my space and time will not be yours space and time. But if we can think in terms of the continuum itself, there is no relativity. The only physical object that is absolute is the combination of space-time. Our biology constrains us from imagining a four-dimensional continuum in which we ourselves exist. In other words, our evolutionary makeup ensures that we can't see the world as it is. This implies that all our theories, whether in chemistry or political science, are destined to be amputated. Just think about that. How horrible it is. In the domain of the complex, we were greatly helped by the physics of the condensed matter and approximations of fluid motions. More complex manifestations, such as the human brain and the human consciousness, are just too complicated and constrain the pursuit of further inquiry. And lastly, in the domain of the epistemology, Gödel's idea of incompleteness completely snatches away all hope of achieving any fulfillment at all. Quantum mechanics' uncertainty, Einstein's relativity, Navier-Stokes' non-linearity, and Gödel's incompleteness. These are the representatives of the four walls that I have called, that have muffled and restricted any further progress of science. People debate this, but they can't produce any evidence to the contrary. To me, there is still hope, and I will tell you how. We have been digging and digging for the last 400 years with better and better tools, both theoretical and practical. These four walls are a sign that we have perhaps exhausted the human capacity to dig further, as both these books argue. John Barrow puts it this way: any universe simple enough to be understood is too simple to produce a mind able to understand it. This thing is called Barrow's uncertainty principle. Here, what has been restricted by the universe is what I call the philosopher's ambition. That creative and curious impulse that sought for the sake of joy. The impulse that sought for the ultimate, or as Einstein is famously believed to have said, that he wanted to know the mind of God. Maybe the universe is just too big, too complex to give any way forward. Perhaps the universe is too complex to satisfy a philosopher. But, and I will show you, there is hope. We have yet to exhaust what I call the engineer's ambition. Hogan puts it this way: what lies ahead involves filling in the blanks of today's big scientific concepts, not uncovering totally new ones. Barrow had put it in his book this way: human progress looks more and more like a race to manipulate the world around us. The physicist Michio Kaku of the City University of New York puts it this way: I find more evidence that the foundations of science are largely over, and we are entering a new era of applications. Maybe we can't figure out the final theory of everything, but what we can look forward to are better cures for our bodily ills, better societal management, better understanding of human psychology, better ways to sustain natural resources, better devices through better AI, faster and penetrating internet reach, and so on. Though we seem to have exhausted our high muscles running for 400 years, we have acquired plenty already. Perhaps it is time that we sit down and figure out what more can we do with this labyrinth of acquired knowledge for a better life on this planet. The misery has lowered but has not died yet. There is plenty to do.